In this project, I will demonstrate how to use low voltage detector in FPV RA0 board. Open eSquare Studio, then click on this file icon, then select New, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this next button. For board selection, you can use this drop down menu, then select FPV RA0 board, then click on next button. For smart bundle selection, we can select none option, then click on next button. Here select executable and no autos option, then click on next button. Here select bare metal minimal, then click on finish button. Now click on open perspective button. IDE will take some time to load your project. By default, IDE will open FSP configuration file. Now click on Stack tab, then click on New Stack, then click on Monitoring, then click on Low Voltage Detection Stack. We need to modify the setting related to Low Voltage Detection Stack. Now click on Low Voltage Detection Stack, then open its properties. Now in Properties window for detection response, select Maskable Interrupt. After that, we need to define a callback function for low voltage detection stack. Now we need to select the interrupt priority of low voltage detection. Now click on BSP tab, then scroll down to find OFS registers. Now expand OFS registers, then expand OFS1 register. Here also the board will monitor the burnout voltage detection level. Below this voltage, the board will be resetted. In first example, we will disable the reset. In second example, I will enable the reset when the voltage falls below this threshold value. We don't need to change anything further. Click on generate project content, then click on proceed button. Now expand src folder, then open halentry.c file. First, I will define these four variables. After that, we can declare FSP error variable. First, we will check the cause for last reset. We can do this by checking the reset status flag register. Now I will check if the last reset was due to the low voltage detection. Then I will turn on LED 1 and turn off LED 2 and wait for 3 seconds to indicate this. From Developer Assistant tab, you can drag and drop pin right function in this if condition and then use RBSP software delay to introduce a 3-second delay. Here we are reading reset status flag register for low voltage detection. After that, I am defining while one loop here. Now from Developer Assistant tab, drag and drop low voltage detection callback function in halentry.c file. Now before entering in while one loop, from Developer Assistant tab, drag and drop low voltage detection open function call in halentry.c file. Then use assert function to make sure low voltage detection open function call was successful. In callback function, we can check if the voltage value is above or below threshold value. We can use p argument current state flag for this purpose. We can take decision according to p argument current state variable. If it is above threshold value, then we can set a flag. If it's below the threshold value, then we can save the critical data to flash or enter in low power mode, or we can initialize the safe reset or power down sequence. But in this example project, I will turn both LED to high position. This if condition will get true if we enable the reset in BSP tab OFS register setting. In if condition, we can check the status flag for GLVD1 status. If the LVD status value is above threshold value, then we can operate in normal mode. To indicate this, I am making LED 2 pin high and LED 1 pin low. In normal mode, we can clear the low voltage detection status. From Developer Assistant tab, drag and drop LVD status clear function call in halentry.c file, and then we can reset the flag variable. Now we don't need to change anything further. Now I am presenting a quick recap for the application source code. First, we are checking the reset status flag register. If the last reset was due to the low voltage, then we are turning on LED 1 and turning off LED 2 for 3 seconds. In while one loop, we are checking LED status flag variable. If it is set to 1, then we are turning on LED 2 and turning off LED 1. Then we are calling LED status clear function call. Then we are clearing the LED status flag variable. In callback function, we are checking the voltage. If it is above threshold value, then we can set the LED status flag variable. If it is below threshold value, then we are turning on both user LED on FPV RA0 board. Now click on your project name, then click on this hammer icon to build your project. After build is complete, right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Now click on proceed button to open debug perspective. In debug perspective, click on resume button twice. After that, check the execution status of the program. It is running successfully. Then we can press the terminate button. Then remove C-type cable from FPB RA0 board. Then attach variable DC power supply with 5V and ground pin of FPB RA0 board. Now I will slowly reduce the voltage. As you can observe in the video, when voltage fall below 2.76 voltage limit, both on-board LED will turn on. When I gradually increase the voltage, LED status flag will be set, and in while one loop we will turn on LED 2 as we can observe in this video. And if we gradually reduce the voltage value below the OFS register threshold value, a burnout will be detected and board will be completely shut down. If we gradually increase the voltage, first low voltage interrupt will be generated and both the LED will turn on. After that, if we further increase the voltage, LED 2 will be turned on indicating the normal mode.